When cleaning data, you will often come across missing or special values. It turns out that missing data, in particular, is a very deep topic. Our goal here is not to provide a complete understanding of missing data, but rather to introduce you to a few useful tools for finding and dealing with missing and special values when the time comes. Not all missing data are created equal. Data may be missing for many reasons, and often the reason they are missing determines how you should deal with them. For example, imagine you're analyzing data from a medical study that required patients to report to a medical facility on a weekly basis. Anytime a patient missed their weekly appointment, the data for that day are simply missing. You realize there's a much higher prevalence of missed appointments among the treatment group. And after some digging, you find out that many patients have been experiencing adverse side effects to the treatment, which is actually causing them to miss appointments. This is really important to know and could have been missed completely if you had just ignored or eliminated all missing data from the start. In R, missing data are represented with NA, which stands for not available. But you have to be careful because they may appear in many other forms if, for example, your data are imported from other sources like Excel, SPSS, or SAS. This means you'll need to search the data very carefully for these different symbols, in addition to watching out for the empty string. There are a couple of special values in R to watch out for as well, although they're generally less common than NA. These are inf for infinity and NaN for not a number. The former may occasionally, but certainly not always, be indicative of extreme outliers in your data, while the latter may mean you need to think through how something is being computed. You might ask, am I accidentally dividing something by 0 in my data? I'm going to walk you through a few ways of finding missing values. We'll use a small data set in the examples, but these methods become particularly helpful when you can't easily view the entire data set by just printing it to the console. We begin by creating a 4x3 data frame called df. Passing df to the function is.na returns a data frame of the same size as df, but with true anywhere an NA was found, and false anywhere that it wasn't. This is interesting, but again, it may not be useful if we're dealing with a much larger data set. Instead, we may be curious to know if there are any NAs anywhere in the data. By surrounding is.NADF with the any function, we are asking if there are any trues in the result from is.NADF. In this case, there are. Once we know there are NAs, a very natural follow-up question is, how many? As you saw in the last chapter, under the hood, true and false are represented numerically with 1 and 0 respectively. This allows us to sum the results from is.NADF to count the number of trues. In this case, it's 3. Also helpful is the trusty summary function, which you saw plenty of in Chapter 1. Summary conveniently tells you the number of NAs for each variable in the dataset, in addition to its usual summary info. Here we clearly see that 2 of the NAs are in column A and 1 is in column B. If you have come to the decision that removing your missing data is appropriate, there are a couple of ways to go about it. The complete.cases function conveniently returns a vector with 1 element for each row of the data. It returns true if there are no missing values in a row, that is, the observation is considered a complete case, and returns false otherwise. This vector can be used to subset the original data frame, keeping only rows with no missing values, as displayed here. Alternatively, the na.omit function does both steps in one by automatically removing any rows with missing values. Let's get some practice working with missing and special values.